one, you really need one.
All right, so starting off with some vocabulary. First off, we have variable. And like we talked about last class, a variable is a letter that represents an unknown value. So when we're not sure what the value is, or we're trying to solve for a value, we use a letter to represent that, meaning that we don't know the value yet. So a variable is a letter used to represent a number. And like we said, common variables we use will be x or y, sometimes n. Depending on the type of problem, we might use other letters, such as C for circumference, P for perimeter. Just be careful that your variables look different than your numbers. All right, next up, coefficient. Does anybody know what a coefficient is? Go ahead. Yes, it's the number in front of our variable. Very good. It's the number in front of the variable. So, let's see here. So I think last class we dealt with, something like this. Alright, so coefficient is this number that's in front of the variable. That 5 there would be our coefficient of this expression.
And it has to be in front of it blue with the multiplication. It can't be in front of it with an addition or a subtraction sign.
Correct.
It has to be right in front of it, blue next to it.
It's the number in front of the variable that is being multiplied. So you might want to make note of that. Multiplied by the variable. So for letter A, who wants to give it a try as to what our coefficient is? What's the coefficient for letter A? That first one there. Go ahead, Muhammad. Very good, -5. Again, just this number in front of our variable. All right, how about letter B? Go ahead, Alma. 7. All right. Letter C, a trickier one. Anybody have an idea what that's going to be? Go ahead, Tom. -1, yes. So we have a negative in front, which means that our number is negative. And whenever you don't see a coefficient in front, it's an assumed 1. We just have one of those. So our coefficient is -1. Likewise, if I had x squared, my coefficient is just 1. When you don't see that number in front, it's an assumed 1. Alright, so now we have what's called an expression and an equation. And students oftentimes get these confused with one another, and it's actually really important that you know the difference between the two. Because when you read the instructions as to what to do, it can give you a clue when you know what an expression is and what an equation is. With an equation, you'll often see the word solve. And so when you see in the instructions solve, and you look and see the equation with that equal sign, you know to get that variable by itself. Oftentimes the instructions for a problem with an expression in it will just say simplify. So you're not trying to get x equals, you're not trying to get a value, you're just trying to combine like terms. So an expression is composed of letters, numbers, and operations. An expression is composed of letters, numbers, and operations. And let's go ahead and write an example with that. So an example of an expression would be 2x plus 3. Notice there's no equal sign. There's no inequality. So it's just this expression here of terms, letters, numbers, and operations. Operations, this word here means plus, minus, multiplication, and division. Those are some operations, what you can do to numbers. So notice an expression has no equal sign. Anybody have an idea what an equation is? That's exactly it. That is perfect. So an equation is where we have an expression equal to another expression. So it must contain an equal sign. Must contain an equal sign. So what we have, it contains expressions within it. But the difference is that there is an equal sign. So an example of an equation is if I had 2x plus 3 equal to 5. The 2x plus 3 is an expression, and the 5 is an expression, a very short one, but it is an expression. So we have an expression equal to an expression. This equal sign is how we know it is an equation. So for equations, we will be solving, and our answer will be x equals. For expressions, we will be simplifying, just combining like terms. Okay. An inequality is similar to an equation in that it contains expressions, but instead of an equal sign, it contains an inequality symbol. And remember, your inequality symbols are less than, greater than, less than or equal to, greater than or equal to. Alright, so again, it's very similar to an equation in that it has an expression, contains expressions, but instead of an equal sign, there's an inequality instead. And that's just comparing the value of two expressions, whether it's larger or smaller, greater than or less than, and it might be equal to. So an example of this would be 2x plus 3 is greater than 5. Okay. This is an example of an inequality. We have an expression, 2x plus 3, and we have the expression 5, and then we have this inequality here. All right. So evaluate. This is going to be a type of instruction you'll be given. You'll see where it says evaluate the expression, or evaluate the radical. Evaluate. That means you're going to substitute a specific value for the variables. Keyword on substitute. So substitute a specific value for the variables. Okay. So evaluate is substitute a specific value in for the variables. So let's say, for example, we have, write this down. All right, so let's say, for example, I have, it says evaluate the expression for x equals 2. Right? So evaluate the expression for x equals 2, and our expression is 5x minus 1. So this phrase here, evaluate, means I'm going to take x equals 2, and I'm going to substitute this in for x here. So what I have then is 5, instead of times x, times 2, because x has the value of 2. Minus 1. So then I get 10 minus 1, and my answer would, 10 minus 1, and my answer would be 9. So evaluate means I'm going to take that value and substitute it in for my variable. Right. And then we have solve. Solve is what, again, is used in conjunction with an equation. We solve equations. And when we're solving, we want to isolate a specific variable. Isolate means to get the variable by itself, get the variable alone. All right, isolate a specific variable. And we will be doing a lot of solving here. Okay, so an example of that, if I were to take my equation here, again, remember that solving is used with equations. So if I were to take my equation, my equation 2x plus 3. If I said to solve this, then what I want to do is get my variable by itself. So I would have to subtract my 3 over 2x equals 5. And then I still have to get x by itself, so divide by 2. And I get x equals 5 halves. So notice solving means I'm going to get that variable by itself, and I have an equal sign. I start off with an equal sign, I finish with an equal sign. So solving is used with equations. And for expressions, we simplify. Any questions on that vocabulary? How many of you have heard these terms before and you're wishing I would just go ahead and get over it? Alright, so we'll move on here. So next up we have exponential powers. Exponentials are something that come up in Algebra 2 as well. And you have the powers here, exponents, and geometry when you're dealing with area. Okay, so exponential powers. Identify the parts here. So this whole thing is what we call a power. When we take a number and raise it to another number. When I say raise it, I mean I'm taking 5 and raising it to 3. 5 raised to 3. Alright, does anybody know what this guy here is called, what that 3 is called? I think I heard someone mumble it. Say it with confidence. Power or exponent? So that little number up top is called power or exponent, and this one specifically is a cube. It is 5 cubed. So this is specifically cubed. So this is called an exponent or a power. Okay. So 5 to the power of 3. Right, does anyone know what the 5 is called? Five is our base. You're going to want to know this terminology because we will use this terminology when we refer to these things. 5 is my base, and it's raised to the power of 3. So we would pronounce this as 5 to the power of 3. Or you would say 5 cubed. Who knows what this means? 5 cubed. What is this the same thing as? What does it mean when you have an exponent? Okay.
5 times 5.
Exactly. So what we're doing here is we have 5 times itself 3 times. So 5 times 5 times 5. This power represents how many times you're multiplying that number by itself. Alright, so let's go ahead and evaluate this. 5 cubed. Alright, so we said it's 5 times 5 times 5. Alright, we're going to try as much as we can to do some mental math and get our brains working. So I want you to keep your calculator off to the side of your desk. And without using your calculator, anybody remember from your multiplication facts what's 5 times 5? Go ahead and say it. 25! Yes! So 5 times 5 is 25. Alright. Now does anybody know what 25 times 5 is? 125. Very good. Anytime that I'm dealing with groups of 25, I think of quarters. Because a quarter is worth 25 cents, right? So if I have 5 quarters, that's $1.25. 125. So good. 5 cubed is equal to 125. Any questions on this? Okay. Let me go ahead and throw up just another quick example. Let's say that I have 2 to the 5th power. What is this the same thing as?
2 times 2 times 2.
Very good. 2 times itself 5 times 2 times 2 times 2 times 2. Alright, let's go and start multiplying together. What's 2 times 2?
7.
4. We have another group of 2 times 2, which is 4. Alright, and 4 times 4? Abdul?
80.
4 times 4.
16.
Very good. 16. And 16 times 2. Very good. 32. So 2 to the 5th power is actually just 32. Okay. Questions on this? Alright, so let's go take a look at some examples of this. Writing it out in exponential form, meaning with the exponent.
Whatever's going on, guys, let's break it up or we're gonna be moving you.
Write it out in words. Expand it out like we just did, and then what the actual value is. And so when it says here answer, you might also see the word evaluate, like we were talking about before. We will. Great. So we have 8 squared. Sorry, I just gave you the answer here. So this is 8 to the 2nd power. In words, we would say 8 squared.
Or you could write 8 in a second. Either one works.
Yep. We can say 8 to the 2nd power. We use squared and cubed, but beyond that, we use 4th power, 5th power, 6th power, 7th power. Right, so expanded would be 8 times 8. And what value is that? Very good. Very good, Trey.
And this is where the calculators are gonna come in super handy, guys.
The calculators are definitely a good way to check yourself, but we definitely want to get familiar with these numbers. You want to be able to pop these numbers out of your head like that. You need to be very familiar with your multiplication facts. It makes things go faster if you immediately know 8 times 8 is 64. Also, when we start to simplify radicals later on, knowing that 64 is the same thing as 8 squared will make things go faster. For when we have a number like 128, knowing that you can break it down to 64 and 2, and immediately know that 64 is 8 squared. Okay, so the next one we have 3 to the 4th. Who has an idea as to how we would write that in exponential form? Go ahead, Mommy. Very good. So that's going to be our expanded form. We have 3 times itself 4 times. And then remember that this big number is our base, and this little number is called our exponent. So what is going to be our base for this? Go ahead, Mommy.
3 would be the base.
Yep.
4 would be the exponent.
Very good. 3 to the 4th power there. Very good. Alright, so let's do a little bit of mental math. 3 times 3 is 9. 3 times 3 is 9. What's our answer going to be?
81.
Very good, 81. Alright, next up. Who has an idea as to how we would write out this?
2 to the 7.
Very good, 2 to the 7th. And Jose? Wait. How would we expand it?
2 times 2 times 2 times 3 times 2 times 2.
Very good. So 2 times 2, 7 times. 1, 2, 3, 4, 5, 6, 7. Alright, let me show you a trick with getting the answer for this real quick without your calculator. So we have 7 of these, right? Anybody remember from the previous page how much were 5 of them? Okay, I'll save you for that. How much was 2 to the 5th on the previous page? Or higher up? Where we did it earlier. How much was 2 to the 5th?
32.
Very good, 32. So we already know that this chunk is 32. And 2 times 2 is 4. Alright, so here, you might need each calculator, or you can quickly just do it out to the side. 30 times 4 is 120, plus 2 times 4 is 8. And so, Joe, what's our answer? Very good. Alright, I want you to go and pull out your calculator. I want to take a look at how we would go about typing that in so you can get that for 128. Okay. On your calculator, you will see on the right side, so here's your calculator, this little caret button, looks like that. That is what we use to get an exponent. So what you want to type into your calculator is 2 caret 7. That is saying 2 to the 7th power. So go and type that in your calculator and you should get it. Yeah, it should be, see the clear button or the division sign? Well, it's in between those. It's in between your clear button and your division sign. What'd you get, Q1? Oh, you just said it. Very good. Alright, so that's how we're going to put exponents into our calculators. Okay, our last one. We have x cubed. What do we say when we have a variable? What's the phraseology reason for that phrase? When we were translating it into verbal expressions on your homework, what did you say when you saw a variable? A number, right. So we have a number cubed. And you could also say a number to the 3rd power. We have x times x times x. And we don't know what the value of x is, so we can't simplify it any more than x cubed. Now, if it asked us to evaluate, let's say that it's, again, using that terminology from before. Let's say it said evaluate for x equals 3. Then our answer would be, instead of x cubed, we substitute in 3 for x. We have 3 cubed. Anybody know what 3 cubed is? You can go and use your calculator for that one. What's 3 times 3? Times 3? 27. There's your answer. Okay. Any questions on that? Let's take a look at the back side here. So radical expression. So we just talked about exponents. Now we have a very important word called inverse. Inverse is kind of the same as opposite. Alright, so the opposite of night is day, the opposite of bright is dark, the opposite of on is off. So if you want to, if the lights are on and you want to do the opposite of that, you would turn them off. Right? So we have kind of the same idea here. We have x squared, we have squared, we have cubed, we have a power. We need an operation to undo that power. Right? Because what if I said, oops, what if I said some number squared is equal to 16? I'm like, okay, great, we can guess and check. 2 squared, well, that's not 16. 3 squared, that's not 16. But so much guessing and checking, we need to be able to actually just get it quickly. And so what we have is called a radical expression here. See, it says radical expression. So what we have is called a radical, and that's this sign right here. That square root sign. You probably hear it more often as square root, but we can also do cube root, 4th root, 5th root, whatever root we want. What this radical does is it does the inverse. So when I take the square root of both sides, then what I'm saying here is, what number can I multiply by itself to get 16? And Joe, what would that be? Good. So the square root cancels out my squared, and I have x equals, square root of 16 is 4. Now, we'll learn this later when we actually start solving. I can have either positive 4 here or negative 4. Because 4 squared is 16, and negative 4 squared is 16. Negative 4 times negative 4 is 16. But we'll get into that more later. I just want you to see why we have this thing called a radical. Alright, so this is called a radical. this piece right here is called your index. You may also hear us refer to it as the root. Index. And then what's underneath your radical is the radicand. So this x value here, that's your radicand. And again, you want to be familiar with this terminology so that when I say, all right, the fifth root of 25, then you know that 5 is going to be your index here, the fifth root, and 25 will be your radicand. Right? So for example, here we have a little 3, the radical, and 8. 3 is my index, and 8 is the radicand. So your radical is the inverse operation of an exponent. So that's what we were talking about right here. It's the inverse operation of an exponent. It tells you what exponent you're dealing with. So here, the cube root of 8 is saying, okay, what number cubed gives me 8? I'm going in the opposite direction. The index tells us which exponent it is. That's what I was just saying here. I see it's an index of 3, cube root, which means I'm going to be dealing with the power of 3. Here my index, actually, so that's what we have down here. If there is no index written in, then it's an automatic 2. It's a square root. All right, square roots are more common, so we use that as our standard. And then if it's anything in that, we write in that number there. All right, so keep in mind if there's no index, we assume it's a 2. So this is square root. Okay. So let's go ahead and look at this one here. So we have the cube root of 8. What we want to know is what number did we cube to get 8? So basically, what number do we raise to the third power to get 8? What number would that be? What number multiplied by itself 3 times gives us 8? Go ahead, Mohammed. Very good, 2. 2 times 2 times 2 is 8. So 2 cubed is 8. So what I'm saying is, okay, this right here, this cube root means what number here must I raise to the third power to give us 8? Any questions on that? Okay, so let's just do another real quick one. What would the square root of 25 be? 5, very good. 5 times 5 is 25. How about the cube root of 27? What number multiplied by itself times gives us 27? Very good, 3. Very good. All right, so let's go ahead and take a look at our calculator and see where we can use this on our calculator. All right, so getting your calculator out. You'll see on the left-hand side, you're going to see x squared is a button. And you'll notice above that is a little blue square root symbol. That whenever the stuff is written in blue, that means you're going to have to hit that second button. See that blue button that says second on it? So in order to get the square root, you have to hit second and then square root. Alright, so second, and then you're going to hit the button that says x squared, which above it says square root. And that should give you a nice square root to pop up on your screen. Alright, so let's go and try it with 25. Square root of 25. So you type in 25. And what do you get? Square root of 25. Hit enter. And you should get 5. Is there anyone that's having trouble with getting that on your calculator? Come around and help you out.
Try 128.
128. Well, what did you type into your calculator?
I don't know.
Definitely grab the
I think you do know what you typed into your calculator, Tayshawn. What did you type in? Or no, Tayshawn's there. Q1's here. I apologize, Tayshawn. If you are actually having trouble, let me know. Alright, so cube root. Anybody have an idea where the cube root button is? This one's kind of hidden. You should see above your x squared somewhere it says math. Sometimes the symbols we use are going to be under that math button. So you want to go to math. Anybody see a symbol that looks similar to this guy? Right, it's the fourth option. So arrow down or scroll down to number 4. Or you can actually hit 4. It looks like this. And then that will give you a nice cube root there. Alright, and then you type in 27. And the cube root of 27, it should give you 30. Alright. Any questions on that? Okay. Alright, so let's go and take a look at what we have here. It says evaluate the expression, give the exact value if possible, otherwise round to the nearest hundred. Alright, so let's take a look at negative square root of 16. We have this negative in front, and so that means we're going to take the square root of 16, and whatever value that is, we'll take the negative of it. So I know that my answer is going to be a negative number. Alright, without using your calculator, anybody have an idea of what the square root of 16 would be? What times itself gives you 16? Very good, 4. And then double check in your calculator and you should get 4. You can actually type into your calculator negative square root of 16. It will get you negative. Alright, square root of 1/9.
Your phone's away if you still have your phone.
Square root of 1/9. So something neat with radicals is that when it's a fraction, you can actually split it up to the square root of the top over the square root of the bottom. So what is the square root of 1? What times itself gives you 1? Everyone knows this answer. 1. 1 times 1 is 1. Alright, what's the square root of 9? 3. So our answer is actually 1/3. Go ahead and type this into your calculator, the square root of 1/9. See what it gives you. Alex, what'd you get when you typed it in? Okay, I'll wait for you. This one right here. Just type in the square root of 1/9. What'd you get? I bet you got it. You're just worried that it's wrong. So you want to hit second the one. There you go. What'd you get? Very good. So when you type in your calculator, you get 0.33333 repeating. Anybody know how to change that into a fraction in your calculator? Hit math, and that first option says FRAC, frac. That stands for fraction. So hit math, frac, and it will convert it to 1/3 for you. All right. So if it's able to be written in a fraction, try math frac and see if it will go. All right. And nearest hundredth, that means 2 places after the decimal. So either one of these answers will work. All right. Any questions on that? Okay. I want you to go ahead and try numbers 3, 4, 5, and 6 with the person next to you. So these 2 rows will pair up, these 2 rows will pair up, and these 2 rows will pair up.
Please come back. Alright,
Alright, so I'll give you about 4 minutes to work on this. we'll come back together and go over the answers. Let's go and take a look at our answers here, what we got. Okay, so what did we get for number 3? The square root of negative 12.25. What happened when you put this into your calculator? It showed error, yes. And it might have even said the word non-real solution or non-real answer. And so the reason, or what we have here is the issue that there is a negative underneath my square root. So let's take a look at a simple example of this. If I have the square root of negative 4, all right? Well, let's look at just positive 4. What is the square root of positive 4? Guys, it should be on the tip of your tongue. What times itself is 4? Good, 2. Because 2 times 2 is 4. But if we try doing negative 2 times negative 2, what does that give us? It still gives us positive 4. Because a negative times a negative is positive. So this still gives us a positive 4. And since the definition of squaring a number means you multiply it by itself, it has to be the same number both times, it's impossible to get a negative number because a negative times a negative is a positive, and a positive times a positive is a positive. And so what we have happening here is there's no real answer. Now when you get to Algebra 2, you'll learn about something called I, which is actually an imaginary number. That is its title. And so I is defined as the square root of negative 1. But we will not deal with that in here. All right, you don't have to worry about it. So there is an answer, it's just it's an imaginary answer, and we do not deal with that in here. That is something for higher level math courses. So what we say is no real answer or no real solution. And I think your calculator even says non-real answer, so you can say that there. All right? All right, I want you to check your answer with the person next to you.
Do you see what she said? Boys,
Yes.
your work. Please put your headphones away. I'm going to take them and keep them the rest of the day if you don't.
I don't even have my phone.
Put them away. Everyone else, please work on this. Boy, stop. When you're talking, I will be moving you and promise you, you will not like where I move you. Also, if it is too much, I will sign you extra homework. Say that again. What time is it?
11:13.
Don't worry too much about that and get your work done. Last class, I was able to give them time to do their homework in class. They mostly got it done. If you guys don't get focused and start working, you're not going to have that. It's going to be hard for you because you won't have calculator.
Okay, so what did we get when we did the cube root of 169? What was our answer for this?
I don't know.
We'll type it into your calculator.
Kept giving me the big one.
A big number. All right, so I want everyone to go ahead, and we're going to do this one together. Hit math. This is what happens when no one gives me an answer. Thank you, Joe. I appreciate it. Scroll down to option 4 where it says that cube root. Go ahead and hit enter. and then type in 169. And what do you get, Q1? It should be a kind of crazy looking decimal.
It's like 200. I don't know. It's like you
Go ahead and type it in again. I'll double check to make sure you have it right.
I think that.
Okay. So you want to get the cube root. So scroll down. So the issue is that you have the square root of the cube root. So you don't need the square root. So see how it's just the cube root now? Okay, so now type in 169. And what did you get?
5
5 point what? 5.287?
No, 5.52877.
Thank you. 5.52877. And it says to round to the nearest hundred. So that's 2 places after the decimal. It's me right here, but we need to look and we see we're gonna have to round. So our answer is 5.53. Alright. Questions on that? Okay. What did we get for our next answer? Plus or minus the square root of 0.25. Anybody want to offer up that answer for us? Make sure you leave it back there. Ivania, what'd you get for this one? Type into your calculator square root of 0.25. 0.625?
No, 6.2, yeah.
6.25? So double check, make sure you're doing square root and not cube root. So do second x squared and then type in 0.25. There you go. 0.5. Good. So we have plus or minus 0.5. And if you think about it, 5 squared is 25. So you can see the similarity there with the decimals. All right, and then finally, cube root of negative 32. What do we get for that? Go ahead, Owen. We get 3.1748. Do we agree with that? Okay, and then we need to round to the nearest hundred, so negative 3.17. Good. All right, any questions on that? Okay, let's make our way to absolute values, and then we'll have time to work on your classwork. All right, absolute value. So absolute value is this symbol here, where we have these vertical bars, and there's going to be some type of number inside. Absolute value is the distance from 0. So if you think of a number line, we're talking about the distance, and distance is always positive. So our absolute value is always going to be a positive value. So when we have the absolute value of 3, we look at 3 and we see it's 1, 2, 3 away from 0. So your answer is 3. Likewise, with negative 1. When I look at negative 1, it's still a distance of 1 away from 0. So your answer is just positive 1. Basically, an absolute value takes whatever is inside, whatever your number is inside, and outputs that, but as a positive value. So it's the same number, just positive. All right, so what's the absolute value of negative 10? Absolute value of 36. 36. Absolute value of 0. How far away is 0 from 0? Good. Absolute value of negative 7. And absolute value of 12. Very good. Now do be careful, sometimes it might get a little tricky because they'll throw signs in front of your absolute value. So the absolute value takes what's inside of it and makes it positive. If there's a negative sign out in front, the absolute value has no control over that. Alright, so let's take a look at just absolute value of negative 2. What is the absolute value of negative 2?
2.
Good. So it's the same thing as negative positive 2. So our answer is then negative 2. So notice that this value here is 2, but our negative has to come over. Okay. What is the absolute value of 19? 19. But we have that negative in front, so it's negative of that. And then likewise here, negative of the absolute value, so we have negative. Right? So absolute value is actually a pretty quick process. Right? If you are ever struggling to remember what an absolute value is, there's actually an absolute value on your calculator. If you hit math and then hit the right arrow button, you'll see it says ABS. That stands for absolute value. And then hit enter and you can do the absolute value of 19, absolute value of 1/2. Alright, any questions on that? Alright, so we're going to go ahead and work on our practice, which is worksheet number 5.